You're welcome to another video. Today you are told to find the value of x in this typical exponential, complicated but simple equation, given that x raised to 3 is equals to 2 raised to x. So we are required to predict the actual value of x when we substitute at this particular point and cube it. Then the output should be equals to that particular answer when we substitute x here to the power 2. So I'm going to take you through step by step up to the final solution, where we're going to find the value of x and possibly prove it. Let us straight away dive into the solution. I know that whenever I have x raised to 3 is equals to x squared, is equals to 2 raised to x, then the first approach that I'm going to use, since the power is unknown at this particular point, then probably I'm going to introduce the natural logs on both sides, so that I have the natural log of x cubed is equals to the natural log of 2 raised to x. Recall that wherever you have log a raised to power b, then this can just be written as b to the log of a. So that is what I'm going to apply here. So 3 comes down as 3 to the natural log of x is equals to x to the natural log of 2. Next step, I'm going to take the natural log of x and x on one side. So I'll divide all through by x. And then I'm going to divide also by 3 on the other side, so that I multiply by 1 all over 3. 1 all over 3. So that my equation now changes to the natural log of x divided by x is equals to natural log of 2 divided by 3. So guys, at this point, I'm going to use the relationship of whenever I have the exponential of a natural log of x. When you take the exponent of a natural log of a certain value, then it goes without saying that the answer just becomes the value of x. So I'm going to write this x in terms of the exponent, because I've seen the exponent to the natural log of x is just x. So I'll write it as the natural log of x divided by the exponential of the natural log of x is equals to the natural log of 2 divided by 3. Next step, you need to recall again that wherever you have an index with this power 1 over n, then this can be written as, whenever you have a raised to power n, then the n can come down up as negative like that. The base is the same, but the power now changes to negative. Applying that here, I'm going to have the natural log of x, the power going to come up as the exponential of negative natural log of x is equals to ln 2 over 3 So guys, at this particular point, I have a negative. The negative have come up. I want to remove this negative by negation. Or by multiplying all through by -1. So that it changes to, I want to multiply both sides by -1 so that I have -1 multiplied by the natural log of x, exponential of negative natural log of x is equals to negative of natural log of 2 divided by 3. So guys, for me to continue solving it further, I'm going to use the Lambert equation. Using the Lambert W formula or the function, I'm going to introduce W on both sides using this function. Then it comes as W in bracket -1. Since -1 times the natural log of x is just negative, multiplied by the exponential of negative the natural log of x should be equals to W of the natural log of 2 divided by 3. I've just introduced the W on both sides. And you also need to recall again that wherever you have the W of a to the exponential of power a, then this goes without saying that the answer is just a. Reapplying this here, then it's very easy to see that this particular function represents a and this particular function also represents a. So whenever I get the W of the natural log of x to this, then it goes without saying that the left hand side is going to remain as the natural log of x. This is what I get, since this and this is the same as a. Should be equals to W of the natural log of 2 divided by 3. Like that. Recall again that wherever you have the natural log of maybe a to the natural log of b, this can be re-expressed as the natural log of b to the power a. This can come here. I'm going to use this here so that this negative gonna come up as the natural log of x power -1 should be equals to the W of the natural log of 2 divided by 3. So guys, if you're still watching us, kindly remember to like this video, share it, leave a comment, and most importantly, turn your notification on. At this stage, I will introduce the exponent on both sides. I will introduce the exponents on both sides of this equation so that I get the exponent of the natural log of x power -1 is the same as the exponent of the W natural log of 2 divided by 3, like that. Recall from our early explanation that when you have the exponent over the natural log of maybe a, then that goes without saying that the answer is a. So here I'm finding the exponent of a natural log of x power -1. This goes without saying that this particular point will change to x, that one, is equals to the exponential of w in bracket negative natural log of 2 over 3 So this can be further rewritten x power negative 1 can be written as 1 over x. 1 over x is equals to the exponential of w to the natural log of 2 over 3, like that. So I want to cross multiply or find the reciprocal on both sides so that I end up with my final value of x. Final value of x will be equals to the reciprocal on this side, 1 over the exponential of w natural log of 2 as our value for the value of x which was required. We can go further and simplify this particular expression using our scientific calculators. So simplifying this using our scientific calculator, I know that the Lambert function w of this, when you get the w of, I'm going to get the w of the natural log of 2 divided by 3. Of course, computing the negative of natural log of 2 divided by 3 in our calculator, I'm going to get negative of 0.2310, meaning that x now will be equals to 1 over the exponent of the w of negative 0.2310 Next step, simplifying this in our calculator, the Lambert function, the w of this, when you take the w of this, you're going to get 1 over the exponent of negative 0.3172, like that. The exponent of negative 0.3172, if you compute it clearly from your scientific calculator, I'm going to get 1 over 0.7282. Of course, I'm just using up to 4 significant figures. There are other values, so I'm just taking the approximate value of it to 4 significant figures. Taking the inverse of this, or 1 over this, you get your final solution as 1.3732, which is the same as the other one. This can be proved, or you can verify it. If you take your calculator and compute, it was x power 3 is equals to 2 power x. Wherever I have x, I want to substitute this, so that when you take 1.3732 to the power 3, computing it in your calculator, you're going to get 2.589 as an approximate value. You can also redo it again. Wherever I have x on this side, to the power 1.3732, computing this in your calculator, you're going to get 2.590, which gives us a clear way that the actual value of x revolves around this figure, 1.3732. So guys, thanks for watching. Kindly remember to like this video. We have come to the end of this particular session. I hope you have learned. Let's meet again into the next video.